Hey everyone, welcome back to Smart Architectural Programming, the companion channel for your programming needs. And this video is a companion video to our book on Introduction to Java. If you're looking to level up your Java skills with clean modern code, you're in the right place. Today we're diving into a powerful feature introduced in Java 17, sealed classes. This feature gives you explicit control over class hierarchies and is a game changer for designing robust and maintainable applications. But with everything, we first need to understand exactly what sealed classes are and how they fit into the narrative of becoming a good programmer in Java. So, first we need to understand what are sealed classes. Simply speaking, sealed classes are Java's way of letting you control which other classes or interfaces can extend or implement them. It's all about intentionality and security in your class hierarchies. Let me say that again so it becomes more clear. Sealed classes are Java's way of letting you control which other classes or interfaces can extend or implement them. It's about giving you the power to be intentional and secure in how your class hierarchies can be distributed or created. A class becomes sealed when it's declared using the sealed modifier and lists the allowed subclasses using the permits clause. So we have sealed clause and a permits clause. So understanding these two is an essential component for you to understand how it works. So as you can see screen here right now, you see in the code that shape is a sealed class and only circle, rectangle, and triangle are allowed to extend it. No other subclass is permitted. Let's clear that with more understanding. So we have sealed keyword here. That is the keyword that tells us whether a class is sealed or not. That's the first point you need to understand with sealed classes. First, it needs to have a sealed keyword, which makes it difficult for makes it impossible for anyone to extend it other than those given the permits. So this is the class name, and now here we have the permits clause. This is important point number 2 that you need to understand in understanding sealed classes. When it's sealed, there needs to be permits. Permits are granted to subclasses that are allowed to extend the main class. So the permits are granted to 3 subclasses: circle, rectangle, and triangle. So unless you're these 3 subclasses, you cannot extend the shape class. So that's how sealed classes work. So let's move a little deeper into the permits clause. The permits clause explicitly lists every class allowed to inherit from sealed class. It makes your design intentions crystal clear. It's a compiled time rule, which means if you try to extend shape from an unlisted class, the compiler will throw an error. So it makes sure that unless a subclass is explicitly listed to inherit something from a sealed class, no other class is allowed to inherit anything, because it would create a compile time error. So with that, let's understand sealed hierarchies and flexibility. So there are 3 important things you need to understand when we're talking about sealed hierarchies and their flexibility. Basically, we need to understand what happens to those permitted classes. They must either be final, sealed, or non-sealed. Those are 3 categories of the permitted classes that are allowed: final, sealed, and non-sealed. You can see those 3 bullet points on the screen right now. So this is where things get interesting. You have 3 options for your subclasses. Final cannot be extended further. I think we talked about this. You can have a final class that extends shape, but it does not allow any further basically inheritance from that subclass, right? That's something we covered in the previous video. Then we have a sealed class that can also restrict its own subclasses. So we have a sealed class in a subclass. A subclass can be sealed, which can further restrict access to of the inheritance for that class. And a subclass can be non-sealed, which basically lifts a restriction and allows uncontrolled inheritance in an object. You can see those keywords I'm underlining in blue. So those are 3 things, but those are the 3 things in mostly to control and manage inheritance within Java. Either you can disallow any inheritance, either you can use sealed classes to allow certain level of inheritance, or either you can have non-sealed classes which do not allow any sort of inheritance. Use non-sealed when you want to reintroduce extensibility in a control part of your hierarchy. Otherwise, stick to final or sealed depending on how you want to control your inheritance. So let's put this into action. Here's a practical example where we can have sealed class, shape class, and 3 implementation: circle, rectangle, and triangle. As you can see, it's a little bit small here because I didn't have much space to put it here. So we have a sealed class here, as you can see, and I don't have a smaller marker than this, but I think I have a highlighter. So you can, and it's really big, but you can notice that we have sealed class here, which basically permits, this is the permits keyword, and then it permits these three subclasses to inherit from the shape class, right? Sealed and permits. Then we have the first class, circle. As you can see here, the circle class. The circle class has the final keyword here, and it extends shape, but it further, any inheritance further from the circle class has been disallowed using the final keyword. Then we have the public sealed class, rectangle, which extends shape but permits certain square and generic rectangle to actually use that, which basically is something that allows inheritance but in a controlled manner. And finally, we have a non-sealed class here, which triangle, which extends shape, which means it can be inherited in an uncontrolled manner. So this is the important thing that you need to get out of it. This design is great for pattern matching in switch expressions and for building scalable, safe polymorphic structures. So when should you use sealed classes, right? What are the exact moments you need to use sealed classes? And this is important because it gives you rules of thumbs on when to use sealed classes and when not to use sealed classes, right? And that's deals with 2 of the circumstances. The third final is pretty self-apparent. You use it, and we've covered in the previous video as well when final should be used. But in the gist of it, you should use it when you don't want uncontrolled inheritance of the class that you're defining. So you use sealed classes when you want to A, enforce a fixed class hierarchy, B, prevent unknown implementations, C, write safe exhausted switch statements, and D, make your architecture more understandable. They're great for domain modeling. Think of state machines, geometry systems, and message types. And there you have it. A quick but powerful dive into sealed classes in Java. If you're following along with our Introduction to Java book, try modifying your class hierarchies using sealed, permits, and non-sealed projects and exercises within the book, which would help you further deepen your understanding about sealed hierarchies in Java. So, got any questions? Drop them in the comments, and don't forget to like, subscribe, and click the bell icon so you never miss an update from Smart Architectural Programming. Until next time, keep your code clean, your models intentional, and your classes sealed when needed.